Okay, guys, so for today, our first video, we're going to just be hitting our first objective from 1-1, and that's just going to be solving linear equations. Okay, so basic solving equations. Let's say that I have 4x minus 1 is equal to 0. Okay, we're just going to start with our properties of equalities by what do I use to balance out a minus 1. Remember, our goal in solving an equation is to get this guy, this variable, alone. So we want to get rid of the 4 and we want to get rid of the negative 1. And it's kind of like orders of operation backwards. Since you already have your answer, you're going to start with adding and subtracting. Always get rid of this constant first. Remember, the number that stands by itself is called the constant, and the number that sits in front and being multiplied by the variable is your coefficient. And you always go after that constant first. So I need to cancel out this negative 1, and I can do that with a positive 1. And remember, whatever you do on one side, and I'm going to go ahead and draw my line. You probably don't draw lines anymore, but because I'm going to be talking about the different sides of that equal sign, I'm going to go ahead and draw that line. Whatever you do on one side, you have to do on the other. All right, so I'm going to draw an addition line here, and I'm going to go ahead and put down bringing my 4x, because that's still there. But I did manage to cancel out that 1. And now 0 plus 1 gives me a 1. All right, 4x means number next to a variable. That is a multiplication problem. So that's 4 times x. And by properties of inequality, what can we do to cancel out multiplication? Division. So we're going to divide both sides of that equal sign by 4. And 4 divided by 4 is a 1. And 1 times x is x. So that's been my success right there. Now, one of the things that we do a lot is we tend to take things too far. So that generally ends up getting punched into the calculator. And that's too much work. You've got your answer already. X is equal to 1/4. Even if your fraction here comes out as an improper fraction, leave it as a fraction. There is no reason to take it as a decimal. Just leave it as a fraction. All right, I'm going to step it up a little bit here, and I'm going to put in some distributive property and some like terms. Remember, distributive means to multiply, right? When you distribute what's on the outside, you have to multiply what's outside times everything inside, no matter how many terms. I have 2 terms inside of this parentheses, so I have to multiply this 3 2 times. That is honestly the most error that people do. They do not distribute times everybody inside of the parentheses. So that is 3 times 2x. That gives me a 6x. And one of the things that I teach my students in order to help maybe to remember to get both, I say it's a wink and it is a smile, hitting both. Wink to the first one, smile to the second, and do not forget to smile. 3 times a negative 3 is a negative 9. So if I were distributing that, and then remember when we have like terms, you must have the same exact variable. 3x minus 4x, that would be a negative 1x. And that's just simplifying, right? That's not solving, that's a simplifying term. Um, what if I had 8y plus 2x? That is simplified. These are not the same, so that you cannot put them together. There is no simplifying that one. One that does tend to trip us up is if I had 8y plus 2y squared. Again, these are not the same. Even though it's a y, this is y to the first, this is y to the second. That's already simplified. Nothing you can do. This is simplified already. So is this. Nothing you can do with these. So let's, missing some letters. All right, let's go to a problem where we can practice some of that. So if I have 3 times 2x minus 1 minus 4x equals 5. Anytime I have parentheses, I'm always going to go after them first. Then I'm going to clean up my like terms. Remember, you can't solve until you get all of your variables into one single term. So wink and smile. 3 times 2x and 3 times negative 1 gives me a 6x minus 3 minus 4x equals 5. I still have some simplifying I can do, so I'm not ready to start solving yet. I'm going to stay right here, and I've got a 6x and a negative 4x. Watch those signs in front. And that's going to leave you with a 2x minus 3 equals 5. All right, now I'm just right back up to that very basic step. Constant, then coefficient. So canceling out a negative 3 with a positive 3. Now I'm in the solving mode. Now it's where I've got to work both sides of that equal sign. All right, bringing down my 2x. Those 3's get canceled. And 5 plus 3 gives me an 8. 2 times x. So I'm going to divide by 2. And that leaves me with x alone and a 4 on here. So my answer is x is equal to 4. Okay. Trying to keep the videos short, but I'm afraid this first one, just because there's so much to talk about when it comes to solving equations. What if I had something like 5 times x minus 1 equals 2x minus 5? And I bring this problem up for a reason, because this is another one we have a tendency to stub our toes on. So if I distribute here, I always work in that distributing. Wink and a smile. 5 times x is 5x. 5 times a negative 1 is a negative 5. All right, so first off, I got a variable on both sides. I can't do this. I can't say 5x and 2x is 7x. I can't do it because it's on different sides of that equal sign. So I can't just simplify them. Okay, so I'm going to go ahead and I'm going to move that whole term, cancel it off of this side, and put it up under this 5x. I'm going to say minus a 2x. It's a positive 2x, so I'm going to do a negative 2x. Because of like terms, I'm going to put it up under that 5x. Now I have canceled it here, and I have 3x minus 5 equals negative 5. All right, here's the part where people tend to stub their toe on this problem. If I'm adding this 5, remember constant first, same basic problem. I get 3x equals 0. A lot of people tell me at this point that there's no solution. Remember, sometimes you have your equations that have one solution, infinite solutions, and no solution. A lot of people at this point tell me there's a no solution, but 3 divided into a 0, guys, is equal to a 0. So we kind of get tripped up on that 0. Don't let that 0 mess you up. Okay. All right, one more of these. Let's go to a lot of cleanup, a lot of simplifying. We're going to do 2 times 5x minus 7 minus 7x equals 3x minus the quantity of 2x plus 8. Okay, so again, I see those parentheses there, so I'm going to clean them up. And one of the things that we want to make sure that we don't forget is right here. There is a 1 there. Even though it doesn't look like I have anything to distribute, I do have to distribute that negative 1. So I have 2 times 5x gives me a 10x. Don't forget to smile. 2 times negative 7 gives me a negative 14 minus 7x equals 3x minus 2x minus 8. Distributing that negative 1, right? All right, so now I've got some like terms I can clean up, and I'm working on one side at a time. Here I have 7x or 10x minus 7x. So that's going to give me a 3x minus 14 equals same side, so I can simplify. Now I got 1x minus 8. All right. When they're on the same side, like the 10x minus 7x, we simplified to a 3x. But when they're on different sides, remember, you can't do that. I can't put these two together to a 4x. I have to cancel it off of one side and move it over to the other. And by the way, it does not matter. If you would like to move the 3x over to the right side, it does not matter what order you want to do that in. So I'm going to do minus 1x minus 1x. All right. 3x minus 1x is 2x. Minus 14 equals negative 8 because 1x minus 1x is gone. All right, so then I have to get rid of the constant. I'm right back at my basic two-step here. If you notice, that's what we do every time. We clean it up till we get back to that basic two-step. So now I'm going to add that 14 to both sides. And I have 2x equals 6. Be careful of those negatives. 2 times x is equal to 6, so I'm going to divide by that 2. And x is equal to 3. Okay? All right, so that's some practice that you need to do on solving linear equations. Couple of things about those linear equations I'm still going to talk about is when they show up with fractions. And when they show up with fractions, what we do most of the time is just eliminate. I'm still on 1.1, solving linear equations. Okay, so I'm going to take a very basic, what if I have 1/5 x is equal to 7 tenths. Now, I think you've probably been taught about your multiplicative inverse. And to solve this, all you do, how do you divide by a fraction? You multiply by the inverse. So I need, since this is 1/5 times x, I need to divide by 1/5. And how do I divide by 1/5? I multiply by 5/1. Right? Whatever I do on one side, I do on the both. All right. So these cancel each other out, and my x is by itself. All right. So then I have 35/10. Or I can reduce and make this 1 and a 2. 5 divided by 5 is 1. 10 divided by 5 is 2. So I can cross reduce on that one. And that gives me 7/2. And again, guys, leave that alone. It's simplified. It's improper. That's okay. You do not have to change this in any way. There is nothing that's going to go into 7 and 2. There's no common factor. So even though it's an improper fraction, it is simplified. So just leave it alone as that. All right. So another thing that we can do, I'm going to rewrite this problem. Another thing that we can do is we can just go ahead and eliminate the fraction. All right. What is the least common denominator or the least common multiple of 5 and 10? I'm going to look at every denominator in there and I'm going to come up with the least one. Well, that's going to be 10, right? So if I multiply and distribute a 10 across the entire into every single term, 10 times 1/5 is 10/5, right? 10 times 1, no, there's a 1 under that 10, so 10 times 1 is 10, 1 times 5 is 5, 10/5, and that makes that a 2x. All right, to everybody and everything, 10 times 7 is 70, 1 times 10 is 10, and that means I have a 7. And then I can divide by the 2, and x is equal to 7/2 again, right? You can eliminate that fraction by distributing across both sides into every single term your least common denominator. Let's say that I have 3/4 p equals 4/5 p plus 1/2. All right, if I were to count by 4, 5, and 2, the smallest number that all of them would go into would be 20. So my least common denominator, my least common multiple is 20. So I'm going to distribute a 20 to every single term. You can never, ever, ever skip a term. So if I do 20 times 3/4 over 1, 20 times 3 is 60. 1 times 4 is 4. All right. 60/4 reduces down to 15p. 20/1 times 4/5. 20 times 4 is 80. 1/5. 1 times 5 is 5. And that gives me a 16p. Okay. Okay. And then 20 times 1 is 20. And 1 times 2 plus 10. Okay. It's the same exact equation. There's nothing different in these two equations. We've just built one that doesn't contain a fraction by the least common denominator. All right, so again, I'm going to say minus 16p. I can't have more than one variable, so I've got to get them put together. And since they're on both sides of the equal sign, I've got to subtract it off 1. Now I've got negative 1p equals a 10, dividing by that negative 1, and p equals negative 10. Okay? And don't forget, I know you all know how to plug your answers in. You can make this a negative 10, this a negative 10. And you would say, what's negative 30 over 4 equals negative 40 over 5 plus 1/2. And that would be true statement. You can check your work all the time. So one that's just a little bit more on here with the fraction. What if I have x plus 1 over 2 plus x plus 3 over 3 is equal to a 1? Well, my common denominator is the 6, right? And don't forget, even though there's no fraction in this one, you still have to multiply by every single term, whether it's a fraction or not. I got to multiply every term. All right, so I'm going to do, and I'm going to rewrite it this way. Just maybe it might help. 1/2 times x plus 1, right? Plus 1/3 times x plus 3 equals 1. That's just taking this, dividing by 3 and multiplying by 1/3. That's the same exact thing. Dividing by 2 and multiplying by 1/2. Same thing. All right, so when I do this 6 times 1/2, that's going to give me a 3 times x plus 1. And 6 times 3 gives me a 2 times x plus 3 equals 6. Don't forget, absolutely everybody. All right, so now I have 3x plus 3, 2x plus 6, whoops, plus, not equal, plus, equals 6. Now I've got my like terms, and since they're on the same side of that equal sign, I can go ahead and simplify. So I've got 3x and 2x. That's going to give me a 5x. A positive 3, a positive 6 is going to give me a 9 and a 6. And I'm back to my basic two-step equation. Subtracting that 9 from both sides. 5 times x equals a negative 3. Dividing by that 5, and x is equal to a negative 3/5. Again, don't do more work than needed. Leave that fraction alone. Okay? All right, before I leave this objective, I'm just going to talk one more problem. What if instead of fractions, I have decimals? This whole same least common denominator business will work for this. This is 8/10, 1/10, 7/10. So the least common denominator for 8/10, 1/10, and 7/10 is, you guessed it, it's a 10. So if I multiply a 10 to every term, I'm going to end up with 8t equals 1 plus 7t. No decimals. As long as I hit every term with the greatest one, then I am good to go. Minus 7t. Now I have 1t equals 1 and t equals 1. Okay? Works the same with the fractions as it does with the decimals. All right. I'm going to hit a new objective. I'm going to start another video on this. So I'm going to stop this one now. We're going to close up.